Hello everybody. Still in Unit 4 here, Quadratic Relations. We're on day 3 now, completing the square part 2. So last week you would have looked at completing the square part 1, and that was involving whole numbers. Now we're going to be looking at completing the square, although some of our problems are going to involve fractions. So we're going to have to work a little harder about this, and we're going to go through a number of examples to kind of highlight this process. But first things first, let's review kind of some of the operations involving fractions, how to apply exponents, how to divide, multiply, add, and subtract, just so that we can have a little bit of a warm-up and a refresher. So, example 1, evaluate the following. We're just going to do these one by one. Okay, so the first one is 3 over 2 squared, or to the power of 2. Whenever you're applying an exponent to a fraction, it just means you want to apply it to both the numerator and the denominator like such, and then you would solve. Well, 3 squared, that's 9, and 2 squared, that's 4. So your answer here would be 9 over 4. Okay, let's keep things going. Same thing here. The only difference between this problem is that there's a negative involved. Okay, if that negative is out front of the fraction in front, you can assign it either, that negative sign, either to your numerator or denominator, and it's the same process here. Well, 5 squared and then 2 squared, you're left with 25 over 4. Well, you should know that even if it's negative, whenever you square a value, it will be positive after that because you're multiplying by itself. So make sure that your answer is in fact positive if you have a negative value. Okay, C5, subtract 3 over 4 or 3/4. Well, when you're adding or subtracting fractions, remembering that you have to essentially find a common denominator. If you have a whole number, I would just use the denominator that's already involved in your problem, which is 4. The only thing is we have to make this have a denominator of 4. Well, if we multiply 1 times 4 to get 4, 5 times 4 is 20. Therefore, our problem becomes 20 over 4, subtract 3 over 4, which is 17 over 4. Okay, moving forward, we're on problem D. D is the exact same, so I'm just going to leave that. It would follow the same process as C here. You're just involving a negative, but essentially still find the common denominator and then just subtract or add. Okay, E, we have a whole number or constant out front, and whenever you have a value in front of a brackets, you know this is multiplication. Another way to think of multiplication of a whole number by a fraction is just make that whole number over 1, so you have 2 fractions involved in your problem. And multiplication is probably one of the easiest operations to involve with fractions. You're essentially just multiplying your numerator, so 3 times 5, that's 15, and 1 times 3 is 3, and that's how you get your resulting problem. Okay, and then we'll do one of these division problems. So we'll do F, and we have 5 over 3 divided by 2. Okay, well, when you're dividing fractions, what you actually want to end up doing is multiplication, and you multiply by remembering what we call the reciprocal of your second fraction, or your second value. So that is 2. The reciprocal is just essentially you have flipped the fraction itself. So if this is 2 or 2 over 1, it actually now becomes 1 over 2 or 1/2. So I have made my operation not division anymore, it's multiplication. And now I've taken the reciprocal of 2, which is 1/2, and you multiply your numerators. 5 times 1 is 5, 3 times 2 is 6, and that is your resulting answer right there. And that's just a little bit of fraction review before we get into completing the square with fractions. Feel free to do G and D there on your own if you want a little bit of extra practice following those examples. If not, be prepared. We're moving forward here with a couple completing the square problems. All right, we're going to do 3 problems here about completing the square using fractions at some point in our problem. So this example here says convert to vertex form by completing the square. Pretty much anytime you're going to convert to vertex form from standard, you're going to be completing the square. So you looked at that process. It's the same steps here. You're just going to have a little fraction work. My suggestion is that maybe you do some of that work off to the side. and it will assist keeping things organized, and that you can, if you're unable to do kind of that that math in your head, then you're able to do that off to the side, and it just keeps everything a little bit more organized. So with completing the square, remembering the first step here is actually factoring out that a value, or that leading coefficient, from both your x squared and your x term, which would leave you with this here. Okay, now at this point we have to look at essentially our new b value, which is our -3, and we're going to do that little operation, remembering using this formula, b over 2 squared, or b divided by 2 squared. Well, that would be -3 divided by 2 squared, which we're not going to make this into a decimal. We're going to apply our knowledge of exponents and fractions and square both our numerator and our denominator, which gives us 9/4. Now with that value, what we want to do is add and subtract that value inside of our brackets, and we're leaving it as a fraction. So 9/4 minus, or plus 9/4 minus 9/4. Okay, and the next step involved in completing the square would be distributive property. We're going to take this value of 2 and multiply it by the value that we are subtracting in our brackets. Okay, so that would be leaving all of this inside of our brackets. 2 times -9/4. Well, that essentially just becomes 18/4. And if you want to kind of know again how I got this, this is what I mean by our fraction or our rough work off to the side. Well, 2 times -9/4 is the same as saying 2/1 times -9/4, which is -18/4. Okay. After that, what we need to do is we need to essentially combine our like terms outside the brackets. And because we have fractions, we're going to want to find a common denominator. Well, the common denominator is going to be 4. Okay, and if we want to make our value of 3 into a fraction with a denominator of 4, we're going to have to multiply it by 4. That's going to be 3 times 4, that's 12/4, minus 18/4. Okay. If we simplify that, 12 minus 18 leaves us with -6/4. Now, I'd also recommend that you reduce that fraction. So if you reduce the fraction 6/4, you should be left with 3/2, because you can divide both of those by 2. And the last thing we have to do is essentially we need to look at what's left in the brackets, and we need to factor it to make it a perfect square. Or remembering our strategy, we can look back to our this step right here, and we can look at what we had in the brackets, which was -3/2. Okay, therefore what's left here is 2x minus 3/2 squared minus 3/2. Okay, every time this value right here, look back to your step 2 and ask yourself the question, what did you get in the brackets? Well, if you look back, we highlighted it, that was -3/2, so this is x minus 3/2, and we have just completed essentially completing the square for our first fraction problem. Okay, let's do a couple more examples. The next example here, okay, we have 3x squared plus 8x minus 10. Same steps. Factor out that leading coefficient, which is 3. This one's a little bit more challenging because you're wondering how you can factor 3 out of 8. But whatever you're doing that, if it doesn't divide out or factor out nicely, then you just simply make that 8 over 3x minus 10. So I've taken that b value of 8 and I have just divided it by 3 because essentially that's what I would do to factor. But I want to keep this neat and organized and I don't want to have any decimals involved. So that's how I'm going to do things from now on. Okay, same process. Well, you're going to use that formula b over 2 squared. In this case, it's 8 over 3 divided by 2 squared. Now this can look a little messy and a little tricky, but do this step by step if you have to, or again, do your rough work off to the side, or if you can do it in your head, that's awesome. Okay, so this is actually, we're just going to focus on what we have here in the bracket, which is 8 over 3 divided by 2. Okay, another way of saying that, if we remember to our warm-up, 8 over 3 times the reciprocal of 2, which is 1/2. If you keep going, well, that becomes 8 over 6 squared. My recommendation is this fraction that's left in the brackets, let's reduce that so we are working with smaller values. You can divide both 8 and 6 by 2, leaving you with 4 over 3 squared. And if you apply exponent to your fraction, remember, and you apply it to both your numerator and your denominator, 4 to the power of 2 is 16, 3 squared, or 3 to the power of 2 is 9. Okay, you're going to go back to your problem, and you're going to rewrite that. And with that value we just got here, 16 over 9, we're going to have to add and subtract that 16 over 9 inside of the brackets. Okay, the next step, as I'm sure you're all thinking, is that distributive property. Take that leading coefficient and multiply it by the value that you're subtracting in the brackets. So that's subtract 16 over 9. And that will allow us to remove that, leaving us with a nice trinomial with some fractions in it in the brackets. And what we have outside here is minus 10 plus 3 times negative 16 over 9. And I'm writing that just so we can see the whole process here. Okay, I'm trying to do every step here so we can break it down. Well, if I multiply this out, I'm going to be left with essentially negative 48 over 9, which is a fairly large fraction. The next step here is going to be kind of simplifying our like terms. Therefore, we're going to have to do a little common denominator fraction work. If you find a common denominator amongst these, so I'm going to just do some fraction work up here. Negative 10 minus 48 over 9. Well, the common denominator is going to be what? Well, you can just simply make it 9, and this becomes negative 90 over 9 minus 48 over 9. Okay, and then you're going to type that in, negative 90 minus 48, you're left with negative 138 over 9. If you want to reduce that, so if you want to reduce that, you can divide both of these by 3, which leaves you with negative 46 over 3. Bring that value back to your problem. And now you're left with this. The last step here would be factoring our trinomial, which we have left in the brackets. Or again, remember, we just need to look back up to our initial step here. What was left in our brackets when we were doing this before we we squared that, and that would be, oh, sorry, that would be 4/3. Okay, and it's positive at that point. So what's going to be left? 3x plus 4/3 squared minus 46/3, and therefore you've completed the square. Now I know this process is a bit tricky. However, again, if you do fraction work off to the side, or if you don't rush and you just kind of lay it out as such, it does make things a little bit simpler. Okay, our last problem here. If you think you have the hang of it at this point, you can go ahead and start working on the assigned work, which is the questions just below here that I'll display in a second. If not, there's one more problem we can do. Okay, so again, follow the steps. Let's factor out that leading coefficient. That leaves us with -6/4x plus 10. Now, at any point in your problem, if you can reduce fractions, you can in fact reduce this fraction right here. So I'm going to, before we even go any further, just to simplify things. So you can divide both those by 2. That leaves you with -3/2. And I've just reduced it. That will make things a little cleaner moving forward, essentially. So I recommend that you do that no matter what. Okay, if we keep going, our next step is to use our little formula and determine what value we're going to add and subtract in our brackets. Well, this is going to be -3/2 divided by 2 squared, which is the same as saying -3/2 times 1/2, which is uh, 9/16, sorry. Okay, what we want to do is simply take that value, we're going to add it and subtract it in the brackets as such, and then we're going to just use distributive property to take that out of the brackets. And if you do distributive property, what you're going to be left with is 4 times 9, which is, and this will be addition because you're multiplying two negatives. -4 times 9, 36/16. Okay, I'm also going to do a little fraction work here, just so I can save myself some space. Well, 10 plus 36/16. First things first, I'm going to reduce that fraction, and I'm going to make that 9/4. If you just divide both things by 4, and then we find a common denominator, which is 4, and that equals 49/4. Okay. That leaves us with this in our problem, and the only thing, again, we have to factor our trinomial that's left inside the brackets here, or we look back up to our original step. What was left in our brackets? That's -3/4. Okay, therefore our remaining answer should be -4. X minus 3/4 squared plus 49/4. And there you go. That is completing the square. So you've taken 2 days to work on that. Some problems involve fractions, some do not. You do need this skill moving forward. It's helpful in a lot of problems. And hopefully you can review that video. If you have any questions, please do ask them on our discussion page. And here are your assigned questions. Not out of the textbook. They're all right here. And then if you have any questions, please ask them, and all the answers to those problems are right below. So best of luck and enjoy.